So the next step of the process is gearing and motor selection. For this setup, we're going to be using a 2250 kV 4070 motor, which is actually designed for 6-cell, but I'm going to be running 8-cell. And this is from the Revo, so it has a bit of super glue for the heat sink still on it. But that aside, this should be a good motor to run on this carbon limitless. As it is very light, it won't need as much motor. So I believe this should be a winning strategy. So the first thing you want to do is you go to your browser and then you search for RC car calculator, and I'll put the link in the description. But go to RC car calculator, and here is how you figure out your gearing. So we're going to put in 2250 kV, and we're going to be running 8 cells, which is way above the rotor limit, but I believe that it should work. For pinion, let's start off with, let's see, oh, that's too high, 34, and then we have a 32 tooth spur, so 32. Then differential pinion for Arma Limitless, the factory one is 13 for the pinion, and then this is 37. So your differential is 37 tooth, your input gear is 13, and then stock size is 108 millimeters. So you hit calculate, and it'll take a bit. So that's way too high. We have it geared way too high here. As you can see, the mile per hour is 293, so we have to drop that down. And the easiest way to do that is putting in a much bigger spur. So let's say we do 45. All right, so we're at a much more manageable speed now. We're at 208 mile per hour rollout, and we can adjust it. At least the way I adjust it is I cut the tire, which I have tires, and I'll show that in another video. But you can drop that by like cutting it down to say 95, and this is for fine trimming and fitment. But see, now we're down to 183.5. But keeping it factory for now, we're gonna go with, let me go back to it, 34 tooth pinion and 45 tooth spur. So let's move on to the next step. So with the available gears that I have, we don't all have, every single gear possible. I'm going to go with 42 tooth for spur and 32 tooth for pinion, and that should give us a 210 mile an hour rollout. So that should be pretty good, and we'll adjust it by cutting the tires, because the body won't actually take a 108 millimeter tire. Tires are a bit too big for this body, so we're going to cut them down. Okay, so I like recording these in real time for the parts that I find, or at least that have taken me a long time to understand. But what I did, this is a perfectly fine working spool. I cracked the top cup. Doesn't matter which side, whatever works on your spool. But now, while holding the gear, which this can be hard sometimes, but you do that and then you wiggle it out just so that you're not really damaging anything. And then this would be better on a clean surface, but I think that is a clean surface. So take that off, and then you get your gear, which I just freshly installed all of this yesterday, but I like doing it. So take it off, and this is another trick I have, is you put the end cup that's still mounted, still prime, you put it on here, and luckily, or hopefully, your gear's easy enough to spin off. So this one, ow, it's not gonna work. So one trick I use here, with the grubs unscrewed a little bit, you can actually, if we can get this right, you can use them to your advantage. So you can do that, just very lightly, not forced, and then, ooh, so that's going to be a hard one. Okay, so very carefully wiggle it out, and then my favorite tool in the workshop, the rubber mallet. So give it one good whack, couple good whacks, and then I find that the MIP metal is pretty good. So you do that, and then you do a bunch of little jabs, and hopefully we'll catch it on time. So can use the bearing for the leverage. There we go. So perfectly primed. You can clean off the thread lock with alcohol. Alright, me being excited as always. It's nice seeing things that you make work, or work-ish. But that's pretty good. We have clearance, got the clearance. Now, the gear actually is exposed at the bottom, but there are nuts, there are screws that are as bottom out, like kind of on a Formula 1 car. They keep the bottom from actually scraping. So the gear should be fine. And now we're gonna mount the motor. Okay, so one issue I found is this motor mount, which is the EMP Spectre. It's a very nice setup, very well made. Has 4 top mount screws so that the motor never moves. Won't work with the 4070. It's too big. It's designed for a 5th scale. But, it uses M4 screws, so I'm gonna tap a hole in the mount and we're gonna go from there. Just as a side note, what I measured the TP4070 is 24 millimeters. So what we're gonna do, my usual go-to is thread lock, but remember that there's a screw up here and it needs its depth. So that might be a problem, but we could just put a smaller screw in it. So what I usually do for this is I go straight to the point with the number 2, so 5/64. Grab this. I know my method is a bit rushed, but I find that it does get the job done. So you line it up. Now I want a bit of offset. So let's do right around there, that's good. And now I could be very precise and do that, but an easier way to do it is you grab a razor and very carefully mark it, and this will move off at that point. So kind of tapping the hole in there, and then alright, so there we have it. We have tapped our screw hole, and just to show you, it does line up. It was a total pain. This thing's still pretty hot, but on to the next part is mounting this. Okay, so another important point is the tick. So this is perfect, actually. You just want a little bit of tick, and the way you adjust it, because this is called mesh. Grab it, and that's binded, so that would be a lot of friction. Motor would overheat. So what you do, you crack it enough. That is a little bit too close. That is perfect, and being very careful, tighten the nut, or one of many nuts, but you still have that tick. And that's how you set your mesh. Like Traxxas, for example, they talk about putting a piece of paper in between the gears. Now that's better for like 48 pitch or 32 pitch, but for Mod 1, all you need is the little click, and you can actually see it. You can actually see the mesh from the side. You see that the gears are touching, and there's multiple gears touching at once, and that keeps the gears good
and the motor healthy.